of SIG. So, I'm the host for today, and I welcome our speaker, Dr. Saurabh Kumar from LNMIIT Jaipur. So, I'll just give a brief introduction about our today's speaker. So, Dr. Saurabh Kumar has pursued Bachelor of Engineering degree in Computer Science and Engineering from Swami Vivekanand Technical University, Bhilai, India in 2010. MTech from Computer Science from Birla Institute of Technology, Mesra, Ranchi in 2013, and he has pursued his PhD in Computer Engineering from Sardar Vallabhbhai National Institute of Technology, Surat, Gujarat in 2019. He has been working on the problems of optimized deployment strategy and localization of nodes and events using IoT for post-disaster management. He has successfully published many conference papers, journal papers, and book chapters with leading publication houses like ECM, IEEE, Springer, Elsevier, etc. He has been an active researcher in the field of IoT, collaborative data processing, multi-agent systems, cyber-physical systems, AI, and wireless sensor networks. He was conferred with 2020 Bliss Award for Best Paper by Oxford University Press for his novel work on localization of events for post-disaster management. In the past, he has also served as an SAP developer and network administrator for 2 years with the mining business of the Aditya Birla Group. Since 2019, he has been serving as an assistant professor in the Department of Computer Science and Engineering at the LNM Institute of Information Technology, Jaipur, Rajasthan, India. We welcome you, sir, on behalf of SIG. So the session is all over you. So please, sir, proceed.
Thank you. Thank you, everyone. Good evening to all of you. I have been told that I have to motivate the listeners here to take up the data science field and excel in that. And for that, I need to tell everyone how to do that. So today in this particular session, I am not going to discuss what is data science in its depth, and of course, I am not going to tell everyone what are the different algorithms related to data science which we are going to, which one should explore. No, but my, task today is to let everyone understand what basically is data science in its very core definition, and how we can excel if we take up this particular career, and what is the current demand by the industry, and where we are. We should judge by ourselves, and for that particular thing we are discussing, and we are in a session today. So today's session is on cracking the data science career code. Our discussion will start from a very basic introduction, and we'll start with a very basic understanding of data science. Then we'll talk about some of the roadmaps related to data science career. Then what is the industry expectation, where the gap lies, and we have to introspect while discussing that particular topic. There we will discuss at length. Then we have one topic which is related to tools, technologies, and certifications, the real world strategy and mistakes that we are doing in day-to-day lives. And then we'll end this session with the question and answer from the audience. And in between my discussion also, if anyone would like to ask something, I will be happy to answer the queries. And if it will be a discussion, I will be happy to be a part of that particular discussion. See, to start with and introducing this particular talk session, my few points. So the first point here says that it's not about learning tools, it's about learning how to think with data. See, what is happening in current scenario, we all are there in in academics. Then similarly, this particular area or domain is being taught currently. Means people have started uh, teaching this particular topic, at least started in school also. Okay, but where we are doing the mistake is uh, that we are trying to learn more and more tools, but we don't know what exactly we want by experimenting on those tools. Okay, so we must understand that we are actually trying to play with data. Play with data means we are trying to analyze, we are trying to find meaning from that data, and then if data are available, then what to do with those data. And then if we talk about the tools, then actually it holds importance. So that's why this particular line holds a very significant uh, you know uh, uh, this is very much significant to all of us. Then my second point says that the data science is not about AI, it's about asking the right questions. So to exemplify this particular statement, right, asking right questions. What do I mean by asking right question? Let us take an example. If I ask you that, we have a transportation system in place, and if I ask somebody that, okay, look into how to make the transportation system efficient. So the first thing what we do is, okay, we all are there, we all are there on the roads most of the time during the day, at least in the mornings and evenings when we move from our own house to our office and back. So what exactly happens when I ask this question, ki, what can we change on road? So on based on our experience, we say that, okay, we can think of giving better signal control, so that the adaptation of signaling can be helpful for those moving on the busiest part of the road. Similarly, one can say that we have to change the way the lanes are prepared or constructed. We have to change the way the the traffic rules are given, and if they are not followed, what to do, what not to do. But the right question here is ki, how much of the problems are coming, and those problems are coming in which aspects of our road transport. So herein, when I say right questions in the form of 5W1H, so 1H expand, 1H actually tells you about how, and then what, when, where, which, and why. So if we ask these 5W and 1H questions, we will be able to actually first, look into from observational point of, aspect to the data what we have. And then if we look into that from the perspective of implementing something for analysis of that data, then it was important. So this is what this particular point is actually about. Then the third point is most important, that your degree won't get you a data science job, your skills will definitely. This is this holds a very important part in our day-to-day life. What is happening in currently with our students, especially, or the students who are in their higher education, undergraduate programs, or even if we say from 9 to 12th or master's degree students, what they are thinking that, okay, if I get a degree in, let us suppose, a specialization or degree in AI and DS, I will be able to get a job. No, you have to think about what are the skills which are needed to get that particular job. Okay, and we are going to discuss that at length here. Also, 90% of students learn data science the wrong way. When I'm saying the wrong way means, uh, we should start actually from data. Now, data can be, gathered in two ways. One is synthetic, and second is real world data. Okay, now what is happening that for a small classroom project, to at least initiate, it's okay if you take some data, you generate some synthetic data, you do some small operations. But if you really want to work and excel in this particular field, you have to do good projects which need real world data. For instance, if you just look into the data you are getting from Kaggle or you are getting from some other online sources, you will find that either they are synthetic or they are real world data. If they are synthetic, somebody has tried to generate that particular data, and if it is real world, somebody has invested some time in gathering that particular data. So what is currently getting wrong, or we should say the mistake which is being done by the students currently is that they are not looking into the the observation of the real kind of data and collection of that particular data. So this is very much important because there are so many factors related to so many factors in analysis of the data which comes, and uh, if when we talk about, for example, if we talk about the false positives, false negatives, even if we say there are redundant possibilities of redundant information in the data collected, so we have to look into how that redundancy is coming. So we have to look into the source of redundancy, and that is very much important when we look into the data collection part of the data science. Okay, and similarly, if we go into data pre-processing, cleaning, creation of model, estimation, all those things when we do, so there also there are so many other mistakes that we are doing, and we will look into it in coming slides. Now, you see why this particular topic is important to be discussed, and why our esteemed university is trying to have an online webinar on this topic, because we have seen in at least last 10 years, 10 to 15 years, that there is an explosion of data. Okay, even 9, 10 years back, the chairman of Geo, Mr. Ambani, he said that the 22nd century will be related to data only, or it will be only solely dependent on data. Explosion of data. You see why? Because we have so many handheld things with us now: mobile phones, tablets, laptops, computers were already there, and it has been utilized since last 30, 40 years. Then the need of so many things, so many information, people who are trying to post information are also numerous, and at the same time consuming that information also numerous. So there is a need for data scientists to look into how to actually organize this data and then analyze and then make useful information from this particular data, or generate that particular information for the benefit of some kind of application. And some application processing is needed. We will see those applications, and therein you will understand where data science needs to be applied and what kind of domains are there where we should work. Okay. Now, generally, what happens that we have a tendency okay, we want to work in the field of data science. Okay, fine. I'm sorry, it's written date by mistake. It is date. It's data science. So, okay, data science, fine. Okay, so which tool to use? Okay, fine. What kind of coding is required? Which platform to do? To do coding on? Okay, is it object oriented, or is it procedural? What to do? Acha, where to write? Oh, it requires data science or data structures or not? Okay, where to read those data structures? Which courses to take? So we are doing collectively wrong in data science is we are thinking that okay, data science means always coding, getting some information, cleaning. No, it's about understanding the data. Okay, and understanding of data actually comes in three important aspects. First, what is the problem, and what that problem actually asking you to solve, what purpose. That is the most important part, first thing that we have to look into. Okay, and then we have to think about that particular problem is related to which application or understanding of business where that problem will be, it requires to be solved, so it becomes very much important. Second, and then the third, which is the core aspect of, or the core structure of this whole discussion, which is statistics. See, 2 3 years back, I saw a reel, and on I think Facebook or Instagram, I don't remember, wherein it said that reel said that statistics was already lying. Mathematicians were working on statistics. Then computer science came, okay, and they consumed statistics, and then they said that it's data science now. Okay, so what I'm trying to tell you with this particular information is that it's not like it's something new. All basic things are required from statistics, then problem solving, and then for if you understand the business where that solution of problem is needed, then you will understand what kind of tools to use to capture those important terms from statistics and work upon the data to produce useful information, and then use that information further for business or some other application purposes. So this is actually the whole data science which we are talking about. Okay. Now, see, data science can be defined in different ways. Okay, I am giving you a very simplified definition to make you understand कि if you are trying to work in data science, then what are the different fields in which you have to you have to excel. Okay, so like we can say that this data science is an interdisciplinary field that combines four important domains. So first is mathematics, then statistics, we have discussed in previous slide also, then programming knowledge, and then the domain knowledge. The fourth one is very important. Okay, and I'm going to tell you in coming slide what I mean by domain knowledge here. And I would like to mention that mathematics means basic mathematics. Okay, basic mathematics involves a person understanding the formal aspect of any problem which is given. For example, if I tell you that you have to move from Pune to Jaipur, okay, and you are given 2 days of time. So the formal understanding of mathematics says that you have to find a route, and that too suitable route. For that, what you have to do is you have to look into the number of travelers, you have to map those number of travelers, you have to map the number of routes, then the cost associated with that particular route, then you have to think about what is the cheapest cost, or I should say the optimal cost. Now, why I am saying optimal? Because here optimality means maybe possible you are saving the time, maybe possible you are saving the cost. Okay, so whatever be your objective, on the basis of that you think. So formally you define okay, these number of person from destination D1 to destination D2, which is where D1 is equal to Pune and D2 is equal to Jaipur, going via three different routes. Now cheapest one is this, in terms of time is route 1, in terms of cost is route 2. A hybrid approach can be taken with two different vehicles in route 3. So if you are good in this particular thing, that kind of mathematics is required here. Then comes statistics. When we say statistics, everything in statistics what we read, given a particular data, what do you mean by average, what do you mean by variance, covariance, what is relation, what is correlation, what is standard deviation, everything related to statistics you should understand in its core. So, and this thing, if you remember, from class 10th onwards we are studying 10th, then 12th, then in our undergraduate program also, and in day-to-day life also we are doing these things. Correct? Like if I ask you given 60 students in a batch of computer science in one university, what is the average mark of a particular course in a particular semester? So what we are doing, we are actually looking into the statistics as a whole. So this is one thing. Then third is programming. When we say programming, here programming means ki you should know how to code. Okay, I'm not saying this on a particular platform P1 or a particular platform P2. Okay, I am saying that you should know how to code. Now, how to code means basic understanding of coding. है ना? It's not like data science is only specifically created for the people who are working in the field of computer science only. It has a variety of applications in different domains or fields. Okay, so it's not limited to only computer scientists that they can code, so they have to do it. No, everybody can do it, but you should know a basic code formation and how to do a code or one platform, which is currently being followed, and a lot of things you can do. You have to identify that, and you can start with your data science projects. And fourth, domain. There are multiple domains. We'll see these things, because currently what is happening that people are starting are taking up random projects, and they are trying to do data science coding. They are saying that we are working in the field of data science, but actually when we ask, even it happens sometimes with students also, when we ask ki, bhai, what exactly are you trying to achieve with this kind of project? So since they don't know the domain in which the data science has its problems and solutions are expected in that, so you should have the knowledge of domain also. Okay, now see, when we talk about data science, it has a pipeline which consists of 6 important key terms. So it starts from and it is a process we need to adopt for working in this particular field. So given data, and we have a source from which the data can be generated, the first task is to collect the data. Then collected data may have uh, you know uh, uh, all the features, everything that are there in that particular data. It may be possible that the data is not in the form which can be utilized further. So when I say not in the form to be utilized further, means it is not clean. Now what I mean by saying cleanliness, first thing, it may have redundant values, it may have missing values, it may have certain values which cannot be understood, so and etc and so on. Okay, so data cleaning is required in the second phase to work further. Then exploration means what kind of, whether it is a pattern matching we need to do, whether we have to do some kind of classification, all those things we have to think about. So exploration is needed. Then modeling means we have to actually model the problem and the estimation in itself, to look into how data will be extracted for the problem being given, and then how the problem will be solved given that particular data and the objective which is provided to you. And then the next one is how the deployment and then the decision making is done on the basis of the all the data collection, cleaning, exploration, modeling, and deployment being. So this is the basic pipeline that goes for data science. Now, if we talk about the key roles in the field of data science, we have data analyst, data scientist, we have ML engineer, so ML machine learning engineer, we have AI engineer, artificial intelligence engineers. And if I discuss about the clarity of these roles, so I can say that the analyst is basically involved with descriptive tasks. Descriptive means looking into the past history, okay, past information. And then the scientist, it is actually looking into the futuristic predictions. Okay, so predictive strategy is taken by the scientist, and ML AI engineers, they are looking into how to build an efficient system to capture the descriptive and predictive side, and then work upon them in a particular system. So the task of ML AI engineer is to look into the production systems. What I am trying to tell you with this particular clarity is that you have these roles in which you can actually think about yourself in near future, and you have to actually work upon by thinking about these roles only to carry forward your task by working on some projects. Okay, now, let's look at the roadmap to data science career. Okay, I have divided the roadmap into 5 stages. The first stage, I'm calling it the foundation stage. And now, from in next 3 slides, I will be discussing the stages. And the duration which I am giving here, so like for example, I am saying that the foundation stage has a duration of 0 to 6 months. Now, this is my understanding, okay, that if a person, whether a faculty member, academician, student, researcher, okay, the first time he or she starts thinking about and take up this a particular road towards data science career, it at least takes in a foundation stage 0 to 6 months to be to get aware about what data science is and what to do in that. So what are the basic skills that you have to acquire in this particular foundation stage? So first is basic statistics. Basic statistics in our undergraduate curriculum also we have, and we have discussed in previous slide also what we mean by a basic statistics. And second is the choice of a programming language that we have to think in our foundation stage. Okay, now this choice of a programming language, very specifically if I say in current scenario, Python is a very good tool or very good language on which you can start your data science career, initiate your data science career from in foundation stage. Okay, so with the kind of libraries we have, and more and more libraries coming for Python platform, it is currently a suitable language for kick starting your data science career in your foundation stage. Additionally, I can mention one more programming language, that is R. Okay, so when I started working in data science, the first language which I started with was R. And I'm saying the choice of a programming language, why it is important, because your choice will help you in taking up your project further. It's not like you have chosen some language because of your suitability, but it is not suitable for taking up projects in data science. Similarly, vice versa can also happen, that you have chosen some language but you are not comfortable in it, so you have to become comfortable. So that's why the foundation stage actually asks you to build these two skills. One is basic statistics skill, and second is the skill related to a understanding and working on a programming language. Now, tools on which you can start with is, as I mentioned, one is Python and second is Jupyter Notebook. If you see Jupyter Notebook, just type on Google, you will find that nowadays Jupyter Notebook comes in 3 different versions. When I worked on it a few years back, so only online version was available. Now it is installable on your own machine also, and it has a cloud interface also, and some additional features uh, with proprietary license also it provides. So that is some other thing. You are getting some more advantages with payment based features. However, for even if you don't go with payment based setup, you can start with Python and Jupyter Notebook in your foundation stage to take forward your data science career. The stage two is all about data handling. Data handling covers data collection and data cleaning. Okay, and if you work on real world data, and here I'm talking about an explosive amount of data. Okay, it's not like a 10 number of data are there. Just may say we have chosen 7 or 3 for testing and 7 or 5 for testing, 5 for training, something like. So it's not like we are doing such kind of thing. Okay, we are talking about humongous data, explosive amount of data. So herein the data cleaning, data as a whole, we say data handling, it takes 6 to 12 months as a whole. Okay, so herein when I'm saying 6 to 12, it's not like these things and you are working on it. I am saying that you have completed your foundation and now you are trying to learn how to do data handling here. For that, I am actually telling you 6 to 12 months it will require to become efficient on it. Okay, now what to learn? So one is data cleaning, second is data manipulation, and third most important is visualization. Okay, in visualization we can have different techniques. I can name some like heat map, We can have a technique, like I'm not remembering, heat map एकदम से मेरे दिमाग में आ गया, it came naturally. So such kind of techniques actually help you in understanding the cluster of similar or dissimilar kind of data. And similarly, you can also think about, have a comparison among data in different ways. And visualization, why it becomes very much important, because when we extract data, it does not has, one or two number of features, it has n number of features. So with n number of features, how will you be able to analyze and show that analysis? And we have 2D or 3D, you cannot go to 4D kind of plots. And if you have that particular capability, even if 4D, you are not moving to 5D now, okay, because that particular technology is still under work. So what visualization tells you is कि among those n features, which features are important to be analyzed and shown, है ना? So this actually takes a lot of efforts, if you looking forward to work upon in stage 2. Okay. Now there are some very basic libraries, if you are working in cleaning, manipulation, and visualization. I am giving you three important libraries in Python. One is pandas, second is numpy, and third is matplotlib. Okay, so numpy, as the name suggests, is used for numerical manipulations. Okay, so whatever numerical data you have, so this library will help you in numerical manipulations of that particular data. Similarly, pandas, it's used for extensive work, other than manipulation, like cleaning, pre-processing, something like that. And then matplotlib is a very wonderful tool, which is used for visualization. It has extensive amount of features which can be used, and you have to, as a data science enthusiast, you have to know how to use those features and what are those features as a whole. We should know that. Okay. Example tasks I have given, like if I discuss the missing value handling, we have to do. Okay. Similarly, data normalization we have to do. So these tasks these tasks come under data handling. Okay. Now, the third stage wherein additional effort is required in the field of machine learning, and it takes 1 to 2 years. Again, I am saying that I am not assuming here that you are a machine learning expert. I am saying that once you have completed till stage 2, now in stage 3, you will go forward and you will do certain activities related to machine learning. For that, you should have skills in it. And what are the core concepts which are required in the field of machine learning? One is supervised, unsupervised, and find the difference between supervised and unsupervised. So I have given one example in the braces. One is prediction in the case of supervised learning. So basically, in supervised learning, we work with labeled data set. Okay, so once the labels are given, so we have to have a classification based on that particular label. And in unsupervised learning, we do not have labels, so it is known as unlabeled data set, and therein we need to do the pattern discovery. We can have an analogy in terms of Aristotle and Sherlock Holmes. So what Sherlock Holmes does, basically, he has patterns and he matches everything and then comes towards his um, a theorem. He moves towards the theorem to understand what is the final conclusion of looking into those patterns, because he does not have any labels related to that pattern. And similarly, in supervised learning, what happens, basically, you start with a theorem and then you move towards the result part. Okay, proving of that particular theorem, whether your theorem is correct or not. So one is related to prediction and second is related to pattern discovery. The third part is very important, and it should be I'm sorry, it should be taken up for any data science enthusiast working with machine learning algorithms, which is model evaluation and validation. There are different KPIs related to model evaluation and validation. I'm not going to discuss those KPIs because they are numerous, and based on the different applications and their needs, these KPIs may differ also. And they become different. But we must understand here that every model that you create, see, now understand, when in machine learning we are saying model, this model is basically an estimator doing some kind of estimation. Okay, so when we say model, so we have created, so model can be named as estimator. This model also can be named as an algorithm. So you basically are creating an algorithm to do certain tasks in machine learning, and whatever algorithm or model or estimator you have created, you have to evaluate and validate your findings or your own discovery or your own algorithms. You have to validate whether they are working properly or not. And these three tasks, understanding and working upon supervised and unsupervised learning, and then model creation of models, and then evaluation and validation of those models, actually it requires a lot of expertise, and that's why this duration helps you in working upon that particular expertise. Some of the common algorithms I have given to make you understand, the machine learning uh, uh, as a whole, very basic algorithms from where you can start, and if you see in machine learning laboratories and in machine learning textbooks, these are the initiate during the initial stage, these algorithms are given. Okay, so what are those? Like, one is linear regression, where we predict numerical values. Logistic regression, which is used for classification. Very simple. You are given n number of people's information, and their age is given, their what to say, their for example, uh, their gender is given. Okay, and some estimation is required based on that gender and age information. Okay, so therein what is required here, because it is a labeled kind of data, herein we can go for classification. The third, algorithm which can be utilized is a decision tree, where we make rule-based decisions, and then clustering, where we group similar data to further perform some kind of processing on those data. If you see, carefully here, if you observe, you will find that here I have given four different types of algorithms and in four different fields. If you want to kickstart your machine learning, you can start with these algorithms by understanding these algorithms, and then carry forwarding those activities to again moving towards devising your own algorithms. Okay. Some of the real world examples where machine learning algorithms are required, for example, predicting house or stock prices, spam email detection. Like, there are multiple emails are coming in your email folder. Okay, and how you will be able to classify it as spam or not spam. So such kind of examples, real world cases can be tackled with the use of machine learning algorithms. Then we have customer segmentation. Like, uh, if there is a festive season, so what happens? We have Mintra, Amazon, and so many such kind of platforms currently available and are selling products. They require the different types of customers. They require to know the needs of those customers, their purchasing power. Okay, and for that, what is required in a festival season? What kind of purchases customers are doing? If it is not a festival season, then what kind of purchases they are doing? Then in purchase also, what kind of products? Then in those products also, again, some sub uh, categories are there which need to be taken care of. So customer segmentation is a very good example wherein the machine learning algorithm plays a very key role. And then comes the most important thing, which I have been listening and uh, you know uh, looking at from last 8 9 10 years, which is recommendation systems. We have been looking into the practical aspect of recommendation system. If you see clearly in our day-to-day lives, in the cases of Netflix, uh, Prime, OTT platforms, wherein if you see a similar kind of movies or TV series, they will those platforms will recommend you again similar kind of whatever you have watched, the same kind of similar genre of movies or TV series they will provide you to watch. Okay, But here in one important thing which people are, missing, and people have started working, researchers have started working, and it still it needs attention, is uh, now also the recommendation systems are working on binary coding on a large scale, like recommended or not recommended. But if we see, our feedback systems does not work on either yes or no. It works on starting from a scale. If we talk about a scale from 1 to 10, then for every value from 1 to 10 in steps of one each, like 1, 2, 3, 4 till 10, we have different opinions, correct? So how to look into such kind of segregation and make our systems learn to give such kind of recommendations? So it's not always like if you watch a particular movie, so that movie you like or you don't like, it's not always like that, correct? You have certain segments of liking, certain segments of not liking, those things. So what we are actually not what we forgot on a larger scale is fuzzy, the term fuzzy systems, है ना, हमने उसको भुला दिया बिल्कुल. But it holds importance here, and we need to involve that part also in the recommendation systems. What is the key outcome of stage 3? You will be able to build models that learn from data and make decisions, okay? And this is the outcome which is expected for stage 4, which wherein we say that you have a specialization now, you are moving towards the specialization now, and wherein I am not mentioning how many years, but 2+ years will be required, okay? And herein we must understand that when I say specialization, what are the domains in which you can apply your data science, and you can find out the problems, you can try to find the solutions of those problems. So I have mentioned some of the domains like natural language processing, computer vision. See, computer vision has a very important role, because now we are talking about intelligent transportation systems, and in there, one of the most important entity, or we should say stakeholder, is the camera which are getting installed everywhere throughout the city. So therein it becomes very much important how the data, now you see, large, I should say, humongous data or explosive amount of data are coming from those camera, and having best resolutions, and at the same time very large set of such kind of data are coming. So it holds, we must think about what kind of problems are there and we need to solve. Similarly, time series analysis, already discussed about recommender system, healthcare analytics, then bioinformatics, discussed about intelligent transportation system, then autonomous systems, retail and e-commerce. So many such kind of fields are there. I have mentioned supply chain, agriculture, geospatial, okay, urban, smart grids. So you can see, if you take up one of the kind of any one of the domain, and you start thinking about getting a specialization foundation, and then moving towards your stage 2, stage 3, and then moving towards the specialization, it will help you in forming, or you should say giving shape to your career in the field of data science. Then the the industry readiness is your stage 5, which I have, which is the fifth and final stage of your data science career in the roadmap towards, the path towards your data science career. This is the fifth stage and final stage, wherein I am talking about the projects, the internships that you are doing. Then optimization of resumes. Now when I'm saying optimization of the resumes, the students, they think about doing lots of projects which hold sometimes no importance at all, है ना? And then keeping it in the resume that I have done so many projects. No, it's not about projects. It's the importance of those projects come if you actually think about what you have gained, and whether you, whatever learning you are getting from those projects, will you be able to apply in the industry where you will be hired or not, Okay, and one thing I have mentioned here, that you should have a GitHub portfolio for initial stages. Why? Because see, GitHub portfolio will help you in two ways. One, to have your own repository, okay, and second, uh, to understand ki what is happening all around the world. Okay, so GitHub is a platform which actually helps you in realizing and understanding all these things. Now, if we talk about the industry expectations and the skill gap related to the industry expectations, so we must first understand what industry wants. So I have segregated it in two aspects. One is technical. So if we talk about the technical aspect of what industry wants, so first is strong coding skills. We have already decided that we will be doing coding on Python or R, but now we should have strong coding skills. Like if I am giving I'm giving a task to you, that you should do this particular activity. These are the constraints: X number of constraints, Y number of activities, Z number of outputs. So you should know how to code those things on that particular platform which you have chosen. Second thing, that we are actually, somewhere we are lagging behind. हम पढ़ लेते हैं in our course, but uh, we do not do this at length, is the database. Okay, so we should know how to, I'm sorry again for the error spelling mistake, it is database, not database. So database handling is actually important, and we should have a command on that, this particular thing. Then ML algorithms. Okay, we should have an expertise on ML algorithms. Then data visualization skills, which I have actually mentioned in my previous slide also, that visualization holds importance, and you should have an expertise in data visualization. So this is the technical aspect. All in all, I have, there are some other aspects, but I have, given four major aspects, under which other aspects also come. Okay. Then the non-technical part. So it is actually important, industry, because it's not always like when you will be given some task, you will be given a room, you have to code and submit that code via email or something like that. You have to uh, come to the market, you have to have a communication with your customers, you have to think, you have to communicate your findings, you have to listen to their problems, and then come up with a negotiation, how to build a particular project and make that particular project successful for that customer. So communication is the key. Second thing, problem solving skills you have or not. And third, most important, business thinking. When I was working in Aditya Birla Group, so when I joined Aditya Birla, I joined it after my MTech degree. And I joined with some aim. I had some aim in my mind. When I joined there, every other people from mining and everybody who joined with me, they said, "Ki, why you being an IT person is coming here?" And what I realized later on, after completion and coming to my PhD degree, one night I was sleeping on my bed. I was going to my sleep, and I thought, what happened with me was my manager made me understand business to the extent that out of 25, 26 people who joined with me, I was the only person who was assigned on 7 projects, and 25 other candidates, they were having 0 projects. The only reason was, during the 3 months of my industrial training, initial industrial HR training, I understood the business by looking into every aspect, discussing and doing all other things that can make that particular make me understand that business very well. So what happens actually, once you understand the business, you will be able to visualize what you are going to do. Okay, so I was given this task of financial module SAP development. So it became very much easy for me to visualize what I'm doing. Even I can. So your customer is not asking you everything to do, but you should have that tendency to make your customer feel very much inclined towards your development by giving them something that will actually help them additional to what they have given as a requirement to you. So, as a non-technical aspect, these three important parts are very much important. Now, what common student gaps we have, like what basically happens that this line is important कि companies hire problem solvers, not library users. And we are finding currently among our students that they are more into, मैं ये भी library use कर लेता हूँ, मैं वो भी library use कर लेता हूँ. I know n number of libraries, but given a particular problem, will I be able to solve that problem or not? Library matters, yes, at the time of implementation, but you have to think of being a problem solver herein. So, what is the expectation and what is the reality? I have tabulated here. If you see, expectation is practical machine learning, you should know, but in reality, what is happening, we are only in theory. Similarly, expectation is to work on real data sets. The reality is clean textbook data you are having, or maybe taking up from Kaggle. So if you do not have real data sets, for example, recently I have asked my students, some of my students are working in the field of transportation system. So I have asked my students to do what? Just go to the intersection, any intersection in Jaipur city, name it, ask, just give me the name, you go there and see for 30 minutes, 1 hour, 2 hours, take ice cream, take some juice, take money from me for those products also, no issues. If you do not have, just stand there and see what is happening. And then if you start taking pictures, photos, videos, and then you will realize that actually the data, when it is collected in real time, it is not that much clean what we get from the data sets available on internet. Then deployment, what we are doing, only Jupyter notebook kind of deployment we are doing. Actual deployment, are we doing such kind of projects or not? Then problem framing is one of the expectation, and what we are doing as a whole. Some copy paste projects we are taking, and then we are building our resumes based on those copy paste projects. So these are actually the student gaps which students have to, or even we have to think about, because we are giving guidance to those students, and even we are working in such kind of fields directly or indirectly. So we have to think in this direction. Now, what are the tools, technologies, and certifications? I am not going to give you the whole at length everything related to tools, technologies, and certifications, but some of the platforms or certifications I will give to kickstart your career. For example, I have already mentioned about programming, Python, R. Anyone you can start with, or both of the things you can work at a time. No issues. When I started learning Python, at the same time I started learning R also. Then I realized I can do certain things in R efficiently and certain things on Python efficiently. And it is my viewpoint. Okay, it's not like you will be able to do the same thing what I'm doing. Okay, and I will be able to replicate what you are doing. So it is upon you. Then data handling, which I have already mentioned. See, Excel is still heavily used, and if you just one generation back, if you just ask your seniors, your parents, your senior colleagues, etc., you will find that they are so heavily dependent on Excel. But even though Excel was good, means I have done coding till coding in Excel also. It was available, and it's currently so many people. Like if you see a CA doing Excel based work, you will be astonished to see what kind of work financial people are doing in Excel. However, it is found that still some lacks are there in Excel, because of which some programming platforms came. So we should know data handling for that, SQL and Excel also. Then visualization, we have two important tools which, if required, we should definitely learn. One is Tableau and second is Power BI. Recently I had this I visited Bangalore to one of my college friend, and I had a discussion with him, and I asked him what is happening in your company and everything. I found what they are doing with Power BI, powerful tool. It's a powerful tool for business analytics. They are doing, amazing things with it. So if you get to learn it, please do that. ML frameworks, to start with, we have scikit-learn in Python, then we have TensorFlow, we have PyTorch. These things we can start up with, if we want to go ahead in the field of data science. Some certifications, see, currently what I found, recently, like in last 6 7 years, what I found that the students are doing so many online things. Am I audible? Am I audible?
Yes, sir, you are audible.
Okay, okay. Actually, the light went off here, so I thought maybe. So, okay, so in the last 5 to 6 years, what I have found that students are not inclined towards doing certifications. Sometimes I get an understanding that um, from what I get a feedback from the students that they are into, they think that so much of the cost is involved, But even though cost is involved, the students don't realize ki what the future holds with these kind of certifications in their career. Like when I never thought what will happen with me, but during my undergraduate, just out of the blue, I came to know that there is an OCA certification, Oracle Certified Administrator certification is there. I just paid 8,000 was the cost at that time. I paid for it. It was very difficult for my father, I remember. But I paid for it. I completed in my first attempt only. And, I ran so many queries, nearly 15,000 Oracle queries I ran. And when I was sitting in my placements, when somebody was asking me about those queries, I never used to write those queries. I used to just, you know, orally, I used to say these queries. And my placement people, hirers, they got so impressed with these things. And it helped me when I worked in SAP, when data handling and all those things were required. So there are three basic certifications, and these are very well-known certifications. One is Google Data Analytics certification, then IBM Data Science, then Amazon Web Services. So AWS ML certifications are there. So if you get a time, please look into these certifications and have it. If you do not, if you can't go for IBM and AWS, try for Google Data Analytics. What is the reality checks, like when we do certifications we think that we will definitely get the job, but that is not the case. Job is actually related to what is your skill. Okay. And projects hold more importance than the certifications you do. It doesn't mean that you should not do certifications, but at the same time you should also focus on doing more and more projects. Okay. But why I'm saying a caution, see, I'm not saying the certifications you should not do, but you should work on projects. Even though, so like one of my friends, he did OCA with me, but he never did so many projects or hands on. So whatever he learned, he completed it, and then he switched his role because he was not interested. If that is the case, it's a different thing. But once you are certified, you should actually work on some projects to realize what the vision of that certification. Now, some of the real world strategies and mistakes that I would like to mention here. One is the winning strategy, how you can win if you go forward with data science career. So I have been mentioning build projects, and for that, three-step learning rule I have actually with me. One is to learn the concept, then to implement the concept learned, and then explain to others for feedback. And the machine learning, you see, this works on the same concept, है ना? So it is a closed loop or open loop kind of concept, wherein in a closed loop you go for implementing some algorithm and then checking whether your algorithm implemented is giving you the exact output or not. If it is not, then based on your feedback you change do changes in your algorithm, and then you and so on, you go further doing these activities. So in the same way, these three-step learning rule will actually help you in winning strategy. Winning strategy wise, it will help you. Okay. Then portfolio. What portfolio must include? So 3 to 5 solid projects. Even three is okay. Even one is okay. Even two is okay. But those projects must be of that much caliber that it has made you gain something in this particular field, gain some skills, acquire some skills. Okay. And preferably on real world problems, I want such kind of portfolios or projects to be done. Okay. Then GitHub repository, I have mentioned it previously. I'm not going to discuss at length, but GitHub repository is required. Then important for coders, your code should be readable. When I was doing my PhD, for example, I'm telling you, I was working on one DRDO project which we took, my supervisor took, and it was related to drone communication. You won't believe that we have written 7,000 lines of code, nearly 7,000, not exactly 7,000, but 7,000 lines of code. And every line has had a comment, And till date, once my supervisor called and said that the people at DRDO they were saying that, wow, what kind of code it has. That every time we have some issue, we are just looking at the comment which is here. So readable code you should have. Okay, modular code you should have, and every module must be understandable. If you are writing X, that X must be known. So this is the kind of coding which is required. Then documentation. How I started or initiated my documentation phase when I was going through the software engineering course. My instructor told me that, Saurabh, you are always installing the project, any software. Are you looking into the installation instructions which are given? Are you reading those guidelines which you are accepting, your terms and conditions you are accepting? You would not believe, I started reading those things, and when I visited my company, when I was hired in my company, and I was given some policy with my team members to make some policy, it was very easy for me, So documentation for a project is actually important, but think from a different perspective. The documentation doesn't mean it holds importance. Why? Because it will actually tell you, okay, this project does what kind of activities, and if stuck somewhere, then what to do, what not to do, and all those things. But at the same time, you actually acquire a skill with documentation where you will be actually needed in some kind of policy making jobs. Okay, so and believe me, such kind of jobs actually help you excel further. Some common mistakes, okay, like learning too many tools. Yes, I am against it. Like, still, if you ask me, believe me, I can say that I am not good with Python. I am not good with Java. But ask me anything in C and embedded C, anything. I nowadays the students say that, hey, C, what is the use of C? I'm telling you, I did my PhD on C, embedded C, so many device programmings and everything. But what I'm trying to tell you with this particular example of mine is that learning one tool is sufficient, but you should have a core idea, core knowledge of that particular. Similarly, if you have no depth in the concepts, it will not help you further. And I have been reiterating it again and again. What is that? Kaggle notebooks, just if you copy those things and do your projects, it will not help you. Okay, statistics, data science is about statistics. I told you about one reel that I saw, and that actually motivated me to and made me understand actually what is data science. Okay, statistics is the core. You look into the statistics. When I started working on R, believe me, I thought that I was good in data, this stats. But when I started working on R projects, some project I was doing, so I found that, it's very difficult to work even with multi-dimensional features, to find the average of those features, to work on standard deviation and then do some kind of manipulations. So such kind of things we have to learn. We If we ignore, it's very difficult. And I have been discussing about SQL. Data handling is related to SQL, so we have to learn that. Reality check. See, we have been discussing about making you a data scientist, correct? But not possible. Possibly, you will not find that particular job at the start of your career. No issue. Start as analyst, start as an intern, junior ML engineer. You start with it, and then gradually understand the business. It is very easy for me, after working for 2 years in some business, that okay, you should understand business, but it is very difficult for you who is into academics, as a student, to understand कि अच्छा ठीक है, no, business सीख लेते हैं. It's very difficult for you. Actual what is happening in business, if you understand, so go inside the it, and then that firm, understand the firm, and then start it. Okay, don't think about कि भाई first job will be data scientist. If you get it, fine. If you don't get it, don't get. discouraged or disheartened. Okay. Now, career path options. So, with data analyst, if you start, you can move towards data scientist. If software engineering you start, you can move towards ML engineering. If core engineering you start, core engineering. Okay, because I have been telling you that it's not only for computer science. So if you have the data science knowledge and domain expertise, definitely you will be able to go further. So this is how you can actually think about the career path options. And yes, I have mentioned it. Your branch does not limit you in realizing it. So what is my message for the audience? So data science is not about tools; it is about how you think. Okay, and think and observe and you know, uh, perceive the data. Okay, that is most important. Consistency beats intelligence in this field. Okay, if you are consistent, no peer pressure. Don't think my friend or my colleague is working better than me. You start. I have given you 5 stages. Take your time. Believe me, if you go through these 5 stages, you will understand after 2 years that yes, I have done very well because I was consistent in my doings. Then start small, but start today. Uh, as an example, I told you now that I am damn good in C. Why? Because when I was in my third semester, when I was learning C, I asked my teacher, my madam was there. I asked, madam, it's very difficult for me to understand. She said, Saurabh, from today onwards, you will not sleep daily at night without doing one code of C. And believe me, I have been not so frequently now, but I have been doing this till now. Also, I do this particular activity. So that day I started, now I'm saying that yes, I'm good in it. If I wouldn't have started that day, okay, chalo, dekha jayega, okay, chalo, ho jayega. When time will require, I will do that. I think I couldn't have done this particular thing. I couldn't have excelled in C. So start small, but start today. Okay. And with this, I'm actually ending my session. My only, if students are there, I don't know how many students are there. I would like to mention one line which is very important in current scenario, which is our goal is to create machines, not to become one. Okay. I want to give you one advice. Just spend 6 months without chat GPT, especially for students, I'm telling you. Just spend 6 months without chat GPT. You would not, what to say, realize, you would not realize, like in December was the first time, December 2025, after listening for so many times and from so many people, first time I opened chat GPT. I even did not search for it. Okay. And what I realized that no issues. I know how to ethically use it. So don't be a machine. We have to create machine. If we become a machine, it's not good for the purpose for which we are actually going forward with this particular, topic, and our career path will be destroyed. Okay. So thank you, madam. Over to you. I hope I could be able to deliver what was expected, and my fellow listeners might have received something, and uh, you know uh, something I am expecting that they learn from this session. Thank you. And I can see Professor Saini is also here, sir. Thank you. I was not knowing. I can see now that Professor Saini is also here. Okay. Hello, sir. Ma'am, over to you. Sorry.
Yes, yes, yes. Thank you so much, sir. Let me say, it was a wonderful session, wonderful presentation, and because generally what we discuss about a one single technology or one signal, a single tool, but it was a complete pathway, and you like actually discussed about like how you should opt the things actually. It is not about the complete technicalities, but how you should go ahead and opt the things how to use them, what should be your perspective. That was the main thing that I want to appreciate about this presentation. So, yeah, so
Any
everyone,
queries from the participants? I
yes,
am
yes,
happy
yes.
to take it.
Yes, we would appreciate if you want to ask anything. Any participants, you can unmute yourself if you have any questions, or you can paste your queries in the chat box.
No issues, ma'am.
Yeah, so I think it is very well explained session already. So, yeah. So thank you so much everyone for attending this webinar. Like, we truly appreciate our speaker as well as all the audience, all the participants. We hope you found this webinar informative and valuable. So thank you. Looking forward all of you to be a part of our further sessions.